Hello, 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 ladies and gentlemen, and welcome back. We're looking at question 8 now on the 2011 Manitoba Math Contest. So, find the least positive integer n, for which n minus 11 over 3n plus 8 is a non-zero reducible fraction, so it's not in lowest terms. Interesting. So, if I had something like, well, n is 12 is out, because 12 minus 11 is 1 on top, and that would automatically make it irreducible. I wonder if they're trying to be sneaky and the least positive integer is something less than 11, because I get the sense from the n minus 11 on top that we're meant to think that it should be 12 or more. If I put 1 in here, we get negative 10, because I didn't say the fraction has to be positive. Negative 10 over 11, nah, that's irreducible. 2, negative 9 over 14, that's irreducible. 3, that'd be negative 8 over 17. Okay, doesn't look like something small is going to work. And I don't want to bore you guys by guessing and checking all the first 10 integers. So let's take a crack at this more normally. So n minus 11 over 3n plus 8 is reducible. If we can find sort of a, b, and d is going to be the key one, so that d is not 1, n minus 11 is ad, 3n plus 8 is bd, and then it'll reduce to a over b. But the key is d not being equal to 1. In fact, we'll specifically say d greater than 1. Okay, because by making a or b negative, we can avoid d being negative. Okay, so this is what we need to have happen. But really what we're looking for is we just want the GCD of n minus 11 and 3n plus 8 to not be 1. Okay, that's really what it means. If it's irreducible, the top and bottom have no factors in common. That's basically saying the GCD is 1. So this is another way to do it. But I'm going to stick with my A's and B's. Okay. And we want to understand, we sort of really need to focus on this D value here. So D divides n minus 11, but it also divides 3n plus 8. Now, I don't know what n is. I don't have an understanding of n. I can't get a handle on it at all. But we can probably eliminate n. So if D divides n minus 11, D has to divide 3 times that as well, because n minus 11 is a factor of 3n minus 33. Now, if D divides 3n minus 33 and 3n plus 8, then D divides their difference. I mean, this guy here is just 3a times D. So if I subtract them, so here I'm doing BD minus 3AD. So this is really just d times b minus 3a. So it still is a multiple of d. But now the 3n's go away, and I'm left with 8 plus 33, or 41. So d has to divide 41. Okay, that's critical here. And so 41 is prime, though, so d is 1 or 41, so I'm going to say d is 41. Okay, we need d to be 41, all right. So n minus 11 needs to be a multiple of 41, right? But also, rather crucially, 3n minus 33 needs to be a multiple of 41 too, doesn't it? And 3n plus 8 needs to be a multiple of 41. So if I were, so let's think about this. So n minus 11, if that were just 41, could we do that? And so then that would have 3n plus 8 is 41 as well. So if that were the case, then n would be 52. And, oh, we don't, no, it's not, it isn't 41 itself, but then 3n would be 156, and then if I add 8, I'll get 164, which is 4 times 41. So for n equal 52, I have n minus 11 over 3n plus 8 is just 1 over 4. Because it's going to be 41 over 164, which is 1/4. Can I go smaller? So n minus 11, it has to be a multiple of 41. But for a smaller multiple of 41, so here we had a as 1, and that gave us an answer. To go smaller, to make n smaller, you'd have to make a smaller. A being 0, you're going to get 0 here, and so n is 11. But then you've got 0 over 33, 0 over 41. But they said a non-zero fraction, as I recall. Non-zero reducible fraction. So what if we go a little lower? A is -1, well then you're going to get n minus 11 is -41, and n can't bounce back into the positives from there. It's going to be -30, not positive. So n equals 52 is the smallest. There we go. That wasn't bad, just a quick little GCD or division work. I thought the fact that we multiplied the 3 was going to come back and bite us, but everything was fine, and we relied on the fact that 41 is a prime. It's not that hard to check 41 is a prime. So what's next? Question number 9, I suppose. So I'm going to be doing question number 9 in the next video. If you haven't tried it already, I do encourage you to stop and try and work it out for yourself, see how far you get with it. Maybe you get it completely. I don't know how hard 9 is. I haven't tried it yet. But you want to see 9, that'll be the next video. If you just want to skip to 10, by all means, go ahead to that one. Thank you guys for watching, and whatever you choose to do, I will see you for more of the Manitoba Math Contest coming up.